Number 7, we're looking for confidence intervals. Part A, new machine dispenser is tested on a sample of 24 containers, and the standard deviation for the sample group is 26 milliliters. Find a 95% confidence interval to estimate the true standard deviation. So we're looking for a confidence interval here, and then this is our formula for a confidence interval. We have our N is equal to 24 containers, and our S is equal to 26. And it looks like sigma is unknown, and so it looks like we just need to figure out what our chi squared sub L and chi squared sub R are equal to. And so for that, we need to go to our table A4, and let's see, we got alpha at 95% confidence level. Alpha is 0.05, and since we're talking about a confidence interval, this thing gets split into 2, so alpha over 2 is equal to 0.025. So that means we're looking at a graph, we're looking at a graph of the chi-square distribution whose area gets split over here, and we're looking for these critical values. And if you look at the conditions for this table, we're looking at the area to the right of the critical value. So area to the right of this critical value is 0.025, and area to the right of the other critical value, the left side is 0.025, so the area to the right is 0.975. It's a 7. So we're looking at these two values, and if you want to look at your A4 table as being a mirror image of what happens to the left and to the right, you can fold it right down the middle, and then you should have equal or complements on either side. Now our N is equal to 24, so our degrees of freedom here is 23. So we're looking at the chi-squared on the left side is 11.698, and the chi-squared on the right side is 38.076. 11.698 and 38.076. Okay, so now you have all your values, and you really just need to put it into the formula. So your sigma is going to be between, this is 23 times 26 squared divided by, notice also the left side takes chi squared sub R, so 38.076. And if you want to look at this carefully, it's just the larger chi-square value would go on the left side because it's in the denominator, and that would make that a smaller value. So once you do the calculation, it'll be clear that the larger value should be on the left. So the same numerator, and your chi-square sub L is 11.698. So we go into our calculator and plug in some of those values. It takes a square root, so we could do all this in one step. 23, or 24 minus 1, times the standard deviation squared, so that's 26 squared, divided by that first chi-squared value we got was 11.698, 689, or I'm sorry, on the left side first, 38.076, and then close the parentheses. And then remember our little trick, second and enter, and then use your arrows to just change it. 11.689, and in this case, oops, I was going to say in this case you can just overwrite it, but I forgot the one more 11 there, so I need to do an insert 1, or you can retype the whole thing, it's up to you, and you get that for your upper limit. So we got our values, and they're already under the square root, so it looks like our sigma is going to be between 20.2 and 36.5. And then we can also write in words what this means to us. We are 95% confident that the true standard deviation is or lies between 20.2 and 36.5 milliliters. Okay, so that's 7A. 7B is another confidence interval problem. We're supposed to treat it differently. And I got the formula down here. Newspaper in large Midwestern city randomly selects 66 home sales and found that the mean is 118,900 and the standard deviation is 3,700. 96% confidence interval to estimate the true mean price of the home. So we're looking at a confidence interval. This 96% is going to throw us off a little bit because we're looking at alpha over 2, so alpha is 0.04 in 2 tails. Or 0.02 in 1 tail. Cut that in half. I just want to show you that unfortunately this is our A4 table. We need our A3 table. If we look at our A3 table, we don't have a 0.04 in 2 tails and we don't have a 0.02 in 1 tail. So we have a bit of a problem here. We can't find it using the table. In a test situation, I'll probably give you a degree of confidence that where you can use a table, but in this case I think I purposely did this so that you are forced to use the calculator. So let's look at our information again. We have a mean and a standard deviation for the sample. We don't have, we're looking for the confidence interval. Estimating the confidence interval for the mean. So this is our formula with a T, and we can use our calculator to get that instantly. So let's take out our calculators. Let's clear this and go into stat, test, whoops, test, and go down to, I think this one, the T interval. And we have some statistics for this. We have 118,000 1900, and our standard deviation was 3700. Our N was 66 homes, and degree is 0.96. Okay, so with a quick calculation here, it took the computer a while. Let me do that again so I could take a screenshot before I did my calculation. So these are going to be the input items. And then the output after you press enter. Would give you an interval in parentheses notation. So I would really like for you to just rewrite this using the appropriate parameter. In this case, the appropriate parameter that we're using is mu. So your confidence interval here would be, let's see, 117,945 dollars to $119,855. And again, we can write this in words. We should practice writing it in words. We are 96% confident that the true mean is between $117,945 and $119,855. Okay. I didn't address this question in the first problem about what your margin of error is. It's kind of not used when we're talking about the confidence interval for the standard deviation, but it would be appropriate to find a margin of error here. And since we can't find t sub alpha over 2, we're not going to be able to use a formula to find a margin of error. So to find the margin of error using the confidence interval that you have, the margin of error is going to be the difference between these two cut in half. So it's 119,855 minus 117,945 divided by 2. So we can suppose we can do that in our calculators. That's 119,855 minus 117,945. I didn't put a parentheses around here. I suppose, well, I just press enter and then I'll divide this whole thing by 2. So 955 is your margin of error. So let's take that, add it in our notes. 955. Okay, so that's confidence interval exercise. That's number 7.